Okay, so permutations and combinations are ways of counting the number of possible outcomes in certain situations. And we'll take a look at some of those today and more of those next week. So one way to count how many different ways things can happen is if you have kind of, I call them discrete events. So think about, you're having ice cream. And so you have either a cone or a waffle cone or a dish, a bowl of ice cream. And then you have all your choices for the different flavors and all your choices for the different toppings. So if you just count how many ways you can do a single flavor and a choice of either a cone, a waffle cone, or a dish, there would be M ways to choose your flavor and N ways to choose what you wanted to hold your ice cream in, and we multiply those. So we would have M times N total possibilities. If we wanted to add a topping, then we would have the number of choices of ice cream, the number of things to hold it in, and the number of toppings. And we would, again, multiply all those together. So this is called the fundamental counting principle. It just deals with picking one thing from each category. So you could see it in something like this. Manuel wants to advertise the number of one-topping pizzas he offers to his customers. How many different one-topping pizzas are available at Manuel's Pizzeria? It says make a tree diagram to find the number of pizzas. So I'm going to make a tree diagram. We've got 3 different categories we're going to choose one thing from. So you can choose either a large pizza or a medium pizza. You can choose deep dish crust or thin crust. And then you can choose either sausage, pepperoni, or cheese. So I'm going to start my tree diagram with the size. So we could have a large pizza or a medium pizza. If we choose the large pizza, then we still have 2 choices for crust. We could either have deep dish or thin. And if we choose a medium pizza, we still have 2 choices for crust, deep dish or thin. After we choose our size and our crust, we have 3 choices for our topping: sausage, pepperoni, cheese. Sausage, pepperoni, cheese. Sausage, pepperoni, cheese, sausage, pepperoni, cheese. So if we make a tree diagram, we can just count the number of endpoints on our tree diagram. So how many possible or how many different pizzas could we get at Manuel's? Well, 12 sounds right. All right, if I count these out, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So one way to do that, and I think it's kind of takes a long time, is to draw out that tree diagram. We could also use that fundamental counting principle, which says take the number of different choices we have for size, 2, times the number of choices we have for crust, 2, times the number of choices we have for that one topping, 3. And 2 times 2 times 3 does equal 12. All right. Try this one on your own. The car that Miss Garcia is buying comes with a choice of 3 trim lines. She can get either the standard, the sport, or the luxury line. It comes with 2 types of transmission, automatic or manual, and 8 different colors. How many different option packages does Miss Garcia have to choose from? And rather than option packages, how many different vehicles could she buy? Is the way that I think about it. So what I'm going to do is mute myself so you don't have to listen to me while you work on this. And I'll give you a minute or so, and then we'll come back and take a look. All right, I should have said go ahead and share your answer in the chat when you and some of you did, and it looks pretty promising. So if we use the fundamental counting principle, 3 choices for trim, 2 choices for transmission, 8 choices for color. 3 times 2 would be 6, and 6 times 8 gives us 48 different option packages. All right. So looking at different kinds of problems, there can be times where we have repetition or where we don't allow repetition. For instance, a license plate consists of 3 letters and 4 numbers in the state of Virginia. If the letters and numbers can be repeated, how many possible license plates can be made? So I'm going to draw this out a little bit because it helps me. So we have 3 letters and 4 numbers. So how many choices are there for that first letter? Yeah, 26. 26 letters to choose from. And if letters can be repeated, how many choices do I have for the second letter then? Still 26. Yep. And what about for the third letter? Still 26. My 1-6 just doesn't look right. There we go. Now, the one part that students sometimes struggle with is this numbers part. So now, how many choices do I have for the first number? Good, good. We have 10. So why do we have 10? Because we could have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, how many choices do I have then for each of the rest of the numbers? I think people often, yeah, 10. It's going to be 10 for all of them. Sometimes we forget about 0, and that's why a lot of times people will think only 9 choices. So there's a way to look at that and to figure that out. If you have a range of numbers, like from 0 to 9, what you do is you take the larger number minus the smaller number and add 1. So that's why we get 10. And now we want to multiply those out. So if I pull up my calculator, 26 times 26 times 26 times 10 times 10 times 10 times 10. Okay, this is the long way to do it, but there you go. 175,760,000, and I'll write that on the page as well. And I said this is the long way because we could use exponents. 26 times 26 times 26 is 26 to the third power. And 10 times 10 times 10 times 10 is 10 to the fourth power. So we could have done it that way as well. We come up with the same answer. All right. So that's with being able to repeat. In some states, maybe you can't repeat letters or numbers. So if in Virginia, they all of a sudden decided, you know what? We don't want people to repeat any of the letters or numbers. They've just got to pick 3 different letters and 4 different numbers. Let's take a look at that situation. So how many choices for that first letter?
26.
Yep, still have 26. And what about for the second letter?
25.
Yeah, excellent. All sorts of people jumping on the chat and unmuting. I love it. And for the third letter?
24.
Yep, exactly. And now we get to the numbers. How many choices for the first number, the first digit in our on our license plate?
10.
Yep. Still,
10.
yep, just like with the first way where we could repeat, we get 10 for that first choice. Now we've made that choice. How many choices for the next number?
9.
And the next number? Yeah, chat's going crazy with 8s. And the last number, the last digit. Excellent, 7. And now we need to multiply those 7 numbers together to find our total. So again, I'm going to go to my calculator. Oh. Yeah, all right. Someone's already on top of that. Excellent. So 26 times 25 times 24 times 10 times 9 times 8 times 7. And there we have 78,624,000 different license plates. So about 100 million fewer than if we allow repetition. All right, let's go to the next question. How many possible 10-digit phone numbers are there? So a few questions we might want to ask before trying to do this. Can numbers repeat on a phone number?
Yes.
Yeah, they can. Yeah, they can. So go ahead to see what you get here. I want to. How many choices for that first digit? Yep. 10 choices for the first digit. And how many choices for the second digit? 10. Yep. Yep. And the third digit and the fourth digit and every digit, there are 10 choices. So I'm going to multiply 10 times. And the great thing is, multiplying by 10 is easy. Every time I multiply by 10, I just add a 0. So I'm going to have a 1 with 10 zeros. So there are 10 billion 10-digit numbers. Or, yeah, 10-digit phone numbers. Now, in truth, there aren't that many because there are some restrictions on, like, the first digit in your phone number can't be 1 because that's an international code for the United States. It can't be 0 because that's an international code for another country. You cannot have the numbers 911 to start your phone number, or 411 or 611, because those are already assigned. But if we could repeat any digit and there were no restrictions, there is the number of phone numbers possible. All right. Letter D. How many unique 5-letter passwords can be made? And for the first one, we will allow repetition. And then for the second one, how many can be made if no letter can be repeated? Excellent. So if we allow for repetition, we're going to get 26 to the 5th power. 26 choices for the first letter, 26 for the second, for the third, the fourth, the fifth. So 11,881,376 possibilities. If we can only use each letter once, a little bit different. So for each letter once, 26 choices for the first letter, 25 for the second, 24, 23, 22. That wasn't good. All right, so I got a little different answer than I'm seeing on the chat. I'm just double checking that I entered my numbers incorrectly. I got 7,893,600. Yeah.
That's what I heard too.
Yep, okay. Okay. So maybe just double checking that if you didn't get that, that you entered in the right values. Um, that happens sometimes. We hit a wrong button and um, we get something that's doesn't quite match up right. All right. So what I want you to do is I'm going to have you do this try now number 2. A lock has the digits from 0 to 39. A series of 3 numbers unlocks the lock, kind of like a lock on a locker. How many possible unlock combinations are there if the numbers cannot be repeated? So what I'm going to do is I'm going to give you some time, 5 minutes. It shouldn't take that long, but what I want you to do is take a couple of minutes, get up, stretch, walk around maybe for a minute or two, and then we'll come back and take a look at that answer. All right, so I'm going to mute and I'm going to let you guys work. And if you have questions, go ahead and throw them in the chat, and I will be happy to answer them as you're working on the problem. All right. So I think the part of this problem that is difficult is we're going from 0 to 39, um, which actually means there are 40 choices. So again, remember, take the largest number minus the smallest number and add 1. So I think if I would have said a lock has the digits from 1 to 40, that would have led to less confusion. So we're just going to take 40 times 39 times 38. And when I multiply those together, I come up with 59,280. 59,280. So a lot of if you started, if you said 39, 38, 37, that would have been 54,854. So some of you replied with that in the chat. And it was just because you thought there were only 39 choices for the beginning instead of 40. All right. So we know that if we have a power, if we're multiplying the same number several times, we can use an exponent. If we're multiplying consecutive numbers, then we use this thing called a factorial. And a factorial says start at this value and multiply every number, every integer less than it, ending at 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. And if we multiply that out, that is 120. And the great thing is most calculators have a factorial key or a way to get the factorial. On the Texas Instruments calculator, the factorial button is in the math menu right underneath where it says alpha, and you want to go to PROB, and it's option number 4. Other calculators also have factorial buttons. A lot of times you just need to find, it should have a button that says PRB or PROB. If you have just a scientific calculator, that's probably where it would be. If you have a different calculator and aren't sure, see if you can find the user manual and then look up in the index factorial, and that should be able to help you. Or you could hang around and show it to me and I can try to help you find it. So 2 factorial would be 2 times 1, just be 2. 3 factorial, 3 times 2 times 1, or 6. And 8 factorial, and this gets kind of tedious to write out. This is why we use the factorial, then we don't have to write all of that, all of those multiplications out. So just showing you again on the calculator 8, math. And I think on the TI 83 Plus, it doesn't do the PROB. I think it just says PRB, and I don't think it has that frac option in this menu. I hit 4, and then I need to hit enter at the end for it to calculate.
When I do that on my calculator,
Yep.
it just shows R and.
Okay. So Grace, I think let's go back to that menu. And I'm wondering if you just pressed 1 or enter instead of 4.
Oh,
Is that possibly what happened?
oh, yeah.
Okay. Great that we could have get that figured out, a little problem solving session. That's awesome. Okay, so 40,320 in for 8 factorial. All right, so factorial would be used if you needed to take every item and arrange it in a specific order or a unique position. So, and we'll see some examples here in just a second. Like right now. So you have 5 players on a basketball team and you want to arrange them in the 5 different positions, point guard, shooting guard, small forward, power forward, and center. How many ways can you do that? Because it's 5 players and we're going to use all 5 of them, it would be 5 factorial. 5 choices for the point guard, and then once the point guard is chosen, 5 for the point guard, 4 choices for the shooting guard, 3 choices for the small forward, 2 choices for the power forward, and 1 choice for the center. Yep. And when we multiply that out, or if we do 5 factorial, that gives us 120. 8 runners compete in the finals for the 400-meter run. In how many different orders can the runners finish the race? So this is 8 factorial. And those two we actually calculated on the previous slide, 8 factorial and 5 factorial. In how many ways can you arrange the letters in the word design? And I guess it should maybe, how many different or how many unique 6-letter combinations can you make? So it's 6 letters. We're going to use all 6. Yep, excellent. To get 720 possible different arrangements. Okay. Try this one. How many different ways can 4 friends line up for a picture? So 4 friends, they're all going to line up. 4 factorial, which is the same as 4 times 3 times 2 times 1. "24 different ways." All right. So that's if we're going to use all of the items. And with factorials, you can do some kind of interesting calculations. So if I took 6 factorial divided by 3 factorial, and I'm going to show you, I'm going to write it out longhand first. If I can write it correctly. And then we'll look at a way that you can shorten that up. Because it's all multiplication, any factor in the numerator will cancel with a factor in the denominator with the same factor. So the 3's will cancel, the 2's will cancel, and the 1 will cancel. So when we multiply this out, we're actually only multiplying 6 times 5 times 4 to get 120. One way to think about this is 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, but 3 times 2 times 1 is 3 factorial. And so 3 factorial would cancel with 3 factorial. That's another way to think about it. So you're not writing out everything, especially if you look at letter B. 18 factorial divided by 14 factorial. 18 times 17, which is going to get written a lot better now. Here we go. Times 16 times 15 times 14 factorial. And I stop at 14 because that's what's in my denominator. And so I can cross those out and then find my answer simply by multiplying 18, 17, 16, and 15. Yeah, so we multiply that out, we get 73,440. Now, if you have a calculator that does factorials, you can certainly use that and do 18 factorial divided by 14 factorial. And your calculator will be able to do that. 18 factorial divided by 14 factorial. And the calculator comes up with the same answer as I had and a couple of you had on the chat. It gets a little more difficult if you have more than one factorial. In this case, if you're using your calculator, and I'll show you that first, and then I'll come back and take a look at it, kind of doing it by hand. We have 20 factorial divided by, and here we need to use parentheses. And we get 15,504. If we wrote this out, what I would do is start with 20 factorial. And stop at 15. That's the largest factorial in the denominator. And I would write out the 5 factorial. And then what you could do is look at, hey, does anything reduce? Well, like 5 times 4 is 20. So that would cancel with the 20. 3 times 2 times 1 is 6. And 6 evenly divides into 18. So the 6 would be gone. And so if I did it by hand, I would take the 19 times 3 times 17 times 16. But using parentheses on the calculator makes it a little bit, I think, a little bit easier to calculate. Go ahead and try 50 factorial divided by 3 factorial times 47 factorial. Remember, if we're using the calculator, we want these to be in parentheses. $19,600. That's what I got. All right, one to try on your own. So this is what I would like you to do. Give this one a try. Put your answer on the chat. I will respond back, and I will use that as our final bit for attendance. So once I see your post on the chat, I will respond back and you can have a fantastic weekend.
Can you go back? I didn't get to
Yeah,
fully see it.
no, that was my fault. I hit a wrong button up here when I was trying to get to the chat. Sorry about that. Is that what you needed?
Yes.
All right. Okay, I've got 5 that I'm waiting for yet. And a couple that took off early.
Sorry. I'm back. Sorry. Is that I went to find a sharpener for my pencil.
All right. All right. Any last guesses here? Grace, are you there?
Yeah.
All right. I'm going to say you are dismissed.
Have a good weekend.
Thank you. You as well. Um, Wendy, I think you just popped on and said you were looking for a pencil sharpener. But we are done.
Yeah.
Yeah, we're done with notes. So this last one, the answer was 134,596.
Wow.
All right, so have a nice weekend.
You too.
Thank you.
Yep.
Luvia, are you there? Give me a shout out. Oh, yeah, all right. You are free to go.
Have a nice weekend.
Thank you. You too. Lily, you wanted the essential question, right? Let
Yep.
me pop back to that. There we go. And I'll move this out of the way, maybe. There. All right. Alex.
Yeah,
All right. Have a wonderful weekend.
you too.
Gianna, we are done with class.
Sorry I joined so late. My Schoology was having problems, so I couldn't really get to Zoom that fast. But I was hoping to catch the class last minute.
Yeah, I will post the recording and the notes on Schoology, hopefully